GM. Today we'll talk about hubs, or specifically how Farcaster works in a decentralized manner with different applications. So we know that Farcaster is a decentralized network where Alice can use an app like Warpcast and Bob can use an app like Supercast. And even though these are two completely different apps with their own databases, Alice can post a message, Bob can reply to it, and Alice can see that reply on her own application. And the way this works is we keep these databases in sync using a network called the hub network. And each application in Farcaster will run its own hub. So you see Warpcast and Supercast have their own here. And when Alice writes a message, like Hello World, it makes its way from the app into the backend, into Warpcast's hub, bounces around the network until it reaches Supercast's hub, and then makes its way into Supercast's app. So we'll get into how hubs do this magic synchronization. And we'll start by talking about the way in which hubs talk to each other. There are effectively two modes: gossip, which is sort of like shouting in a loud room, or gRPC, which is like having a conversation with a single person. So gossip is efficient. Messages get broadcast to everybody in the room, but it's lossy because you don't know who heard it, and some people might have missed the message. gRPC, or the conversational mode, is slow because you can only talk to one person at a time, and there's overhead to having multiple conversations. But it's very reliable. You say something, you know the other person heard it, and then you send the next message across, and so you never lose messages. In an ideal world, we just use gRPC because who wants to lose messages? But the challenge is that there are a lot of messages, thousands per second at times, and there are a lot of hubs, up to 1,000 in some cases, and so gRPC itself isn't enough. So we actually use a two-phase sync process where we use gossip to send out messages, and 90, 95, maybe 99% of messages usually get delivered over gossip. And then we have a secondary process which runs occasionally where hub can figure out all the messages that it missed over gossip from another hub, and then using this slower conversational method can go and fetch those messages for itself. So let's dive into how hubs actually work beyond just the communication layer. So if you think about it, hubs are split into three different sections. There's the interfaces, which talk to the external world. There's the application logic, which deals with when something new comes in, a new message comes in, how it actually gets handled, and what messages are valid and what messages are invalid. And then there's a persistence layer, which actually saves these messages so that they can be read by applications. So at a very high level, we have the gRPC and gossip boxes that we already talked about. We have a link to an Ethereum node, which usually pulls in data about what users have signed up, who owns certain accounts, and all of that. And all this is fed into the engine, which you can think of as a router. And the router sends data to a couple of different places. First, it sends data to the stores. And the stores are part of the hubs which deal with logic for very specific types of data. So if you send in a cast, for example, it goes to the cast store, which knows that a user has a certain limit, like Alice is only allowed to store 5,000 casts. And it also has a bunch of checks, like making sure the cast is not too long or that it doesn't have too many embeds, and rejects any messages that are invalid. The second section is the sync engine, which is used to enable the diff sync process that we talked about earlier. And so this part of the system just keeps track of what message IDs we've seen, and then when hubs talk to each other, it's used to quickly calculate the missing messages and then download them using the network interface for gRPC. So let's look at the life cycle of how a cast would move through the system from end to end. Let's say that a cast is sent in via gRPC. So warpcast.com sends a message. It calls the submit message endpoint on its hub. So it comes in here, makes its way to the engine. The engine does some simple validations and checks, like making sure that the message is signed. And then it sends it down to the store, which does a lot more detailed specific checks, like the ones we just talked about, which then writes it to disk. Then the store sends a signal back to the engine saying the message was accepted, at which point the engine sends it to the sync engine. Now the sync engine makes a note that this new message and this message ID was written down, and it will send a note back to the engine, which takes the message and then sends it out over gossip to all of its peers. So at this point, we've sort of blasted out the message to everyone we know, and those hubs are going to see the message now come in through gossip and then go through the same loop all the way and have it committed to their stores and gossip them out to their peers. So this is how hub-to-hub communication happens. And in follow-on videos, we'll dive deeper into each of these sections and how they work mechanically.